Okay, we'll fix up that calendar here shortly. Okay, got to make a video, and hopefully this is pretty decent. Silence. Okay. Um, I actually missed the rest of the day Friday. I had to actually get my car worked on, so I was here for you guys, right? I wanted to keep it secret so that seventh hour didn't know they could steal all the answers from you, and then I wasn't going to be there. So I did keep it kind of secret on purpose. Okay, so all this first stuff I'm going to kind of skip over. The teachers last year just tried to make a point that these two things in two different ways are not the same. So sine of 30 plus 60, there's going to be a sum and difference identity that's going to be introduced to you today. Well, 30 plus 60 is 90, sine of 90 is 1. What they're trying to show is this does not equal if I separate those two into sine of 30 plus sine of 60, because obviously this does not equal 1. So it's really not a big deal. I'm going to skate over this real quick. And then if you look at the graphs of these two, this is a different set of angles, sine of x plus pi, comparative sine of x plus sine of pi. You don't get the same graph. So therefore, this is another proof that these aren't equal. All right, big deal, whatever. We cannot make up new identities. Here is the identities right here. And I just had a conversation with our two other math teachers that teach this. This will have to be memorized. All right, so you have to memorize this group of identities. So what I have highlighted here is, and maybe I'll go back and take this off, how you can memorize these. So I'll take this off for a second here. All right, so let's look at the schematics of the sum identity for sine. Notice sine, the SIGNS signs are the same. See that? So sine of alpha plus beta, and again, get used to alpha being that letter, Greek letter, and recognize it. Sine sum, we have a sum in our formula. So I would highlight that as the same, all right? And then notice sine's formula or format, it's sine cosine plus sine cosine. So, and I'll show you what that means in a minute when we actually have angle measures in there. And then difference is difference, but then notice the schematics. It's the same, sine cosine minus sine cosine. Notice how I'm saying that we'll switch angle measures on that second one to make it easy. So I do like saying sine cosine instead of cosine sine because I can. It's commutative. Multiplication is commutative. I can switch. I don't know why I'm choosing a different color, but different than yellow. We got a difference for cosine. Cosine, the signs are not the same. So the cosine sum formula is, and then another difference is it's cosine cosine minus sine sine. So the cosines are together minus the sines are together. So it's just pattern recognition is all I'm kind of covering here. I know this is coming out of left field. There's really no deriving this formula. The first part of the notes were just to show what the formula is not. All right, and you can't make up, a formula. And then this, notice the signs are different again, and it's still cosine cosine plus sine sine. So the formatting's the same for the cosines. The signs just switch, and the signs are opposite of how they start. The sine formulas, the signs are the same. And then I'm going to use my highlighter for tangents. Very unique formula, way different than the other ones, but I want you to see that the numerator, the sign is the same. Okay, so tan alpha plus beta equals tan alpha plus tan beta. The sign is the same up at the top. On the bottom, 1 minus. Switch. And then tan tan. All right. And then I guess I'll use blue for different. No, wrong. Yellow for same. The numerator follows the sign for tangent. So tan of alpha minus beta is tan alpha minus tan beta. And then the sign switches on the bottom, but also it's 1 plus tan tan. Okay, so no deriving this formula. It's just something that's thrown at you. It's true through just, proven in the past, let's just say, and we're going to move on and use them. Okay, and then where do you use them? In questions like this. 15 degrees is not on your unit circle. Not. So I cannot get an exact answer. And then I will just make this like, why do we need exact answers? Just gonna throw this out there, even if you're not gonna be this. Engineers need exact answers so that parts fit when they make their stuff, whatever the stuff is that they make. So exact answers is, and I need exact answers to, go into space. I know I talk about space a lot, but it's because astrophysicists use math in order to, travel the planets and find out, how we're going to get there and where they're going to be located when we get there. Needs to be exact. For every decimal you're off millions of miles. All right, so that's just the argument. The argument is we need to get exact answers sometimes in engineering, and that's it. All right. So, number one, you have to create some sort of summer difference that equals 15 degrees. But it's got to be numbers that are on our unit circle. All right. And I do have degrees. So, good thing I've been talking about degrees all year long. So, we know 45 is an over what? What's 45 and over what? 4. And then we know 30 is an over what? 6. So, I can have this conversation with you. I've done it all year long, even those note cards online. It starts with a degree measure, then a radian measure, then the evaluation of that trig function. So you've been trained. Okay, so how does this work then? You use your formula. Look at and try to remember. Okay, remember for cosine, it's cosine, cosine. This is why I didn't really say the angle measures with letters. And then what is the SIGN? Actually, I should use blue. Is it plus or minus? It's plus because we got to think of opposites. So that's why I use blue on that to go along with what I had up there. And then it's sine sine. And I'm going to leave degrees. We should be able to handle degrees and know that a 45 is an over 4, a 30 is an over 6. Let me grab my highlighter again just to highlight the sign change, SIGN. All right. And then I can't help you if you don't know this. Cosine of 45 is root 2 over 2. What's sine of a 30? What's sine of a 30? Everyone have accessed a million times this year. So then what is cosine of a 30? It's the other one, which is what? And you're not going to get very unique answers here. Not going to get very unique answers. You don't know that yet. This is brand new. You're going to see a lot of these fractions the same, right? So you're going to see a lot of root 6s over 4. You're going to see a lot of root 2s over 4. But just we'll leave that alone right now. All right, root 2 times root 3 is root 6. 2 times 2 is 4. Root 2 times 1 is root 2. 2 times 2 is 4. This or this could be the answer. Do not make that root 8. You're making up a math. That's not how you add radicals. Not at all. Not at all. All right. Probably gonna cowboy this and move this. What happened? Somebody said something. Okay, I thought I heard something. As if I forgot something. All right. 255. Guess we'll force a sum on this one. I could do a difference. I think I could do either or. Ooh, I got to think about it though. 225 is a nice angle measure, right? Okay, and actually you may not be so good with that. All right, so let's talk about that for a minute. Why did I go 225? How far is 225 away from 180? How far is 225 away from 180? 45. It's a 45 in quadrant 3. So this might be what you're not so trained on. So we'll have to think about degrees a little bit more. I like it. And I'm going to leave it. I'm not converting to radians and then go from there. Because radians, requires fractional work, and we know how we are about fractions, right? Not everyone likes the fractions, let's just say. So I think we really got to commit to this degree thing. And just remember in quadrant 3 or 2, you're based off of 180, how far you are away from 180. So verbalizing some angles like 150 degrees, if that resulted. 150 is a 30 in quadrant 2 because it's 30 away. 135 is 45 away from 180. So that's a 45 and 2. One more, 120 is 60 away from 180. So 120 is a 60 or an over 3 if you want. So this is an over 4 in quadrant 3. That's obviously an over 6 in quadrant 1. All right, and 225 plus 30 is 255. We're good. All right, some of those other things that I said, I think, what is 120? I can't do math right now. 120 and 135, right? 120, just what I said. So another option would have been 120 and 135. Maybe don't write it, just look. And then those are the ones that I just said. That's a 60 in quadrant 2, and that's a 45 in quadrant 2. So all you got to do, you got to play the game, find some sum of the angle measure that ends up being angles on your unit circle. But again, I'm a little worried about you guys knowing degrees because we didn't do degrees much. So that's why I'm just kind of hashing through this real quick. But let's stick with this one. And then the rule for sine is it's sine cosine. This is how I said this, or this is why I said it this way. So I don't really have to memorize the angle measures where they go. I just got to switch. Okay, and then for sine, the signs are the same. So this is a plus. Okay, so here's your memorization factor, which is not very hard. Look at the difference between sine and cosine. For sine, it's sine cosine. For cosine, it starts cosine cosine. All right, signs are the same. And then you switch them. So it's sine. I like writing sine again. I already did sine of 225, so now it's sine of 30. I already did cosine of 30, so now it's cosine 225. All right, so that's how I do it. I don't necessarily do a cosine sine on the second one. I switch the angle measures because it's very easy to do so. Oh boy. Yeah, of course. I don't know. Just get this every single day for the rest of the year and waste blue papers. Okay. All right. So sine 225 is negative. You're in quadrant 3. I said 3 and then 3 glitched in my brain. Root 2 over 2. And then cosine. What's sine of a 30? I'll say it a million times. What's sine of a 30? 1/2. So this is root 3 over 2. If you still don't know your unit circle, you're done for. It's over. Sine of a 30 is 1/2. Where's he getting these ratios from? From 2 months ago. Cosine of negative, or 225 is negative root 2 over 2. Did you see that little warning on your sheet you got Friday? It's coming back. The unit circle is coming back. All right, and then look at what you got for a ratio. There's that negative root 6. There's that root 2, but it's negative this time. Oops, sorry, that's a 4. That's a 4. That's a 4. Hopefully this video makes it. I have a thing in my calendar that last year we had an error in making the video. It was fun. Okay. All right. Oh, I don't know why I was going to go down to number 6 or 5 there. We got to go to this one. All right. I guess I'm getting a little sloppy with my writing here. This is what I meant about radians. Radians requires fractional work. And you're going to see 12 a lot because the common denominator between of 12 would be 3 and 4, like if I go in reverse. So I'm probably dealing with over 3s and over 4s. Could be an over 6 as well, so on and so forth. So you're going to see this denominator a lot. And then you got to create, go ahead and try to create who minus who. Come on, we know it's got to be a minus. So do an unreduced fraction. Who minus 2 would be pi over 12. You think about that with your friends. And I think I can only think of 2 possible options. 2 possible options. Okay, but again, radians deal with fractions. Okay, and then hopefully you came up with either, I'm trying to think, 4 pi over 12 minus 3 pi over 12, right? Or 3 pi over 12 minus 2 pi over 12, because 2 pi over 12 is pi over 6. I'll start with that first one. 4 pi over 12 minus 3 pi over 12. For your purposes, write it like that first, so it does end up equaling pi over 12 in your mind. But then when we go ahead and write this in our formula, go ahead and reduce. 4 over 12 is 1 over 3, so this is pi over 3. And then it's sine cosine. Okay, so the rule for sine is sine cosine. Sines are the same, sine cosine. All right, and that's how it works. 3 over 12 is pi over 4, and then it's minus, and then it's sine the other angle measure. Love doing it this way. It makes it a lot easier. And then cosine of the other angle measure. You got to switch them out. All right, best way to do it. Hey, what's sine of an over 6? 1/2. So sine of an over 3 is root 3 over 2. Lo and behold, look at what fractions we're going to get again. Cosine of pi over 4 is root 2 over 2. It's really a wax on, wax off using these formulas, knowing they exist. There's much more applications to it. This is like ground one, like level one of just using these, and you're not going to get many unique answers. Okay, sine of pi over 4 is also root 2 over 2, and then since sine of pi over 3 is root 3 over 2, cosine must be 1/2. All right, it's always those switch on the 30s and the 60s, the over 6s and the over 3s. Lo and behold, here we go again. Root 6 over 4 minus root 2 over 4. So just a little playing around with the signs, S-I-G-N-S, for these answers. So you're not going to get much uniqueness here. All right, the one that you are not going to like is tangents. It's because of fractions. Let me go ahead and do this real quick. Another cowboy baby. What? What just happened there? Okay, I'm going to shrink this down here so it's not in the way of this one so much. All right. Here's what we got for tangent. Well, first of all, go ahead and give me the two fractions on your paper. It's so simple. What equals 7 pi over 12? That ends up being an over 4, an over 6, or an over 3 when you reduce. All right, if you can create it yourself, you therefore memorize it better. So a form of wax on, wax off. Geez, it's already 16 minutes in. Okay, and the answer for that was very simple. 3 pi over 12 plus 4 pi over 12. If you did 4 pi over 12 and 3 pi over 12, you're fine. Obviously commutative. That is 7 pi over 12. Now, the rule. I guess I'm going to go off the page here. It's tan, and what is it? It's tan plus tan. 3 over 12 is pi over 4. And it's plus, these follow. I'll grab that yellow. Okay, these stay the same. The numerator follows the whatever you started with. In this case, it's a plus. And then it's tan, obviously, pi over 3. And then that's good. Now I just write on the bottom one, opposites. Flip the signs. Maybe flip's not the right word, but anyway. And then it's tan, tan. I'll tell you why you don't like this one, and I'll tell you how the points usually shake out on this. Probably right now, a 1/2 point, just for memorization. Maybe another 1/2 point for knowing what tan of over 4 is. I'm holding up my hand. Here's an over 4. Tan is sine over cosine. I love tan and cotan with the hand. All right? And that is a 1. Right? So tan of over 4 is 1. So is cotan of an over 4, 1. For those that still do not have the unit circle memorized. All right, and then I'm holding up the hand for tan again. Here's the over 3 finger. I wish I could have the camera up here, but the video doesn't allow me. Here we go, complaining about making videos again. But anyway, it's sine over cosine, root 3 over 1. All right, so it's root 3. So tan of over 3's is root 3. Tan of over 6's is root 3 over 3. Cotan flips, right? Just kind of going over the unit circle again. Once you get that down, this is easy because you got those same ratios again, right? And then this is worth 1 point out of 3 or 4 at this point. Then this is where the math gets all nuts. I'll have people doing this. Can we do that? Can we cancel those two? You're gone. That's why someone just shook their head. Yes, you better unshake that head, all right? Because that is not what you're supposed to do. And that's where this gets into, it really just gets into rationalization and can we. But let me just write this cleaned up for a second and then show you what happens next. I guess this would be a 3-point question. Right now you have 1 out of 3. You've employed the formula correctly. You've evaluated the unit circle. Now can you get a final answer? And how you do this is rationalize. So we must reach way back in our brain here. How do I rationalize a radical that's 1 minus root 3? We multiply by the conjugate. So I'm writing that in red because that came out of my head and that just rhymed. I'm a poet and I didn't even know it. All right. So in the bottom, 1 times 1 is 1. I'll put that down there. Root 3 times negative root 3 is negative 3. The middle term falls out. I should not in this class have to show the O and the I of FOIL. But up on the top, we don't have canceling. We have 1 times 1. We have 1 root 3 and another root 3. That's 2 root 3's. And then we have root 3 times root 3, which is 3. So the numerator does have a middle term. The denominator, the whole point of the conjugate is getting rid of that radical down there. Did I do something wrong? No? No. Whatever I do to the top, I must do to the bottom. So it must be, I must pick something to multiply both by the same. Well, I still have to simplify this. So it would be 1 plus root 3 squared, but I still have to multiply it out and clean it up. Okay, so no, I can't leave it like that if that's what you're asking. Because watch what happens. 1 plus 3 is 4. So it's 4 plus 2 root 3. And then on the bottom, I get a negative 2. And you can bust this up. This is why this is still worth, like, there's another half point that people get wrong all the time. They just do this. They take the 4 and the negative 2 and cancel. And that's a 6 over 5 equals 2 error yet again. All right, so that's a lot of things that people do fractionally that just cannot happen. 4 over negative 2 is negative 2. Negative 2 over negative 2 is negative 1 root 3. So this is the cleaned up final answer for that. And it's a nice exact form. Now I will tell you, your answers for tangent questions as well are very common. Like, you get very common answers for this. Because we're kind of stuck in the realm of 30s, 45s, and 60s, but this formula goes beyond this. Like I said, we're level 1, just here's what it is. Wax on, say it. And all these questions today are more about memorization, too, of memorizing these rules so you know they exist. So we do keep it simple, all right? And that is the fact. Okay, I do like these because it does say evaluate each of these expressions. This is just a reverse analysis. Which formula is this? Is it the cosine or the sine formula? And is it sum or difference? It's cosine, and which one is it? Sum or difference? It's difference. So this actually equals cosine of 55 minus 10. Look at the formula. Look how it looks. It's cosine alpha. Oh gosh, that was an attempt at alpha beta. And then this is alpha beta here. And the formula is cosine of alpha minus beta. I mean, it's flat out. This is how all the variables match up. All right, so let you look at that for a second. You want to flip your notes over. By the way, what is 55 minus 10? That's why this one works, because then I can do this without a calculator. That's just root 2 over 2 and it's over. So is everyone okay? Did I do something wrong? You all right? Okay, next. Which one is this? Is it sine or cosine? Is it sum or difference? Sine and what? Difference. Now, careful. They did write this in the right way. Sine of 20, cosine of 80. That means 20 is first. So this is sine 20 minus 80, not 80 minus 20. All right, look at the formula. This represents alpha. This represents beta. Alpha, sorry, I got to squeeze that here, beta. All right, so it's sine alpha minus beta. Subtraction is not commutative. Because 20 minus 80 is negative 60, and that's in quadrant 4. What's the sine of 30? I'm going to keep asking this till people get this down. What's the sine of 30? So it's the other one. What's the other one? Root 3 over 2, and if you still don't know these ratios, you're on Pluto. All right? And then this is in quadrant 4, so it's negative. Pluto. Okay? Pluto. All right, here we go. We love radians because we love fractions. But what does this represent? Sine or cosine? And is it sum or difference? It's not hard. It's not hard. It's not hard. Oh, and then look at this. 5 pi over 12 plus 7 pi over 12. So it's the cosine sum emulation. That's what it's mirroring. And then that ends up being cosine of pi. I always do this. Yoink, yoink, yoink. Look at how fast that was. -1, 0. That's it. There's pi. So cosine is x, the x coordinate, if you just deal with the unit circle. But it's -1 over 1 if you want to throw an r in there. Kickser. Okay, so it's still on a quadrantal, draw it just to make sure. Okay, all right, going pretty fast because this can go fast. It's really not that. And wait till you see the homework. Your answers are all going to be very similar. Very similar. Okay, and then what? It's easy. Is this tan sum or difference? Sum or difference? Difference. The difference is in the numerator, so therefore it's tan difference. Tan difference, so it's tan of 40 minus 10. Very simple section. All right. Tan of 30. I'll raise the hands again, even though we should already know the answer is root 3 over 3 because what I just told you before. Tan of a 60 is root 3, or tan of it over 3 is root 3. Tan of an over 6 is root 3 over 3. But here's the hand. Here's 30. Square root of 1 over the square root of 3. Sine over cosine. Bottom fingers over top fingers. All right. Just trying to rotate around different ways of getting these answers. Just knowledge, knowing. If you don't know, you can use a trick and it still goes fast. And you're able to go fast with it. Okay, now here comes identity time. So we are at the 26-minute mark. Okay, we're good. Establish each identity. So actually, it's just a prove. So it's just like your last test. Oh, and I didn't finish that. So I did leave after Compass. It was nice enough to come through Compass for those 7th-hour people that show up. Then I went home and took care of my car. But what was I going to say? I was going to say a point about that. Oh, well, you just took this test, and I have not graded it. That's what I was getting at. I haven't graded it because I wasn't here, right? So I came here this morning and picked up the papers. We'll work on it today. But what's more complicated, left or right? It's simple. Left. So we're going to do the left. And what are we going to do with the left? We're going to do the rule. So step 1 is do the rule. Okay, just do it. It's sine cosine. And then sine is the same. And then it's sine cosine. I love doing it that way. Then I just switch the angle measures. It's very easy for my brain to handle that. All right, so sine cosine minus sine cosine, switch the angles. Okay, and then if you need to, here's that point right up there. That's 0, 1. So what's sine of pi over 2? 1. So I go ahead and replace that. This is your proof. This is your logic, as long as your logic is correct from one step to the next. This one doesn't evaluate. What's cosine of x over 2? 0. All right. And then all you got to do is write this when you're done. 1 times cosine is cosine. 0 times sine is 0. I have the right side. And that's it. That's our logic steps. All right. It's very, very, very easy. Okay. So that's how we do an identity with these identities. I know that's like a double whammy there, but that's true. Okay. Next one. I guess I'll do colors here. Obviously left. Okay, and then obviously we have the tan difference rule. So obviously, what is the tan difference rule? It's tan minus tan. Okay, so this is a variable, if you will. And then it's over 1 plus tan. And then number 2, let me get this. Okay, what's tan of 2 pi? Well, here's 2 pi. Same thing as 0. 1 comma 0. So tan of 2 pi is y over x, 0 over 1. So tan of 2 pi is 0. My hand just made that move there. Minus, this is just like a variable, over 1 plus 0 times tan of theta. Okay, and then all you got to do is clean up. Clean up. Everyone do their share. All right, so on the numerator, we get negative tan of these guys probably don't even know that reference. I'm getting so old. All right, 1 plus 0 times tan is 1. I think that's good enough. So we could see that that ends up being that. I don't have to rewrite that as just negative tan theta. I'd like to see that 1 though, just so you know it's 1 plus 0 tan, which is just 1 on the bottom. Okay, so just employ the rules and it gets real easy. Still have to know your unit circle values. We'll go back to red. Obviously, it's the left for purposes of getting this moving, and it's cosine, cosine. What's the sign? Plus or minus? Plus or minus? Plus or minus? Minus. Wax on, wax off. Just play the game. And then sine, theta. Okay, and then real quick off to the side, we got pi again. You could have looked at it over there. I already wrote this. Sorry, my brain glitched there. All right, so cosine of pi is -1. Cosine theta is left over there. Sine of pi is 0. And let me get my numbers here for cleaning up. Oh, I hate when that heater goes off. Heater! There's no heat ever coming out of there. But anyway. All right. 0 times sine is 0. It's just basically write it. We know this. Okay. And then we just draw the arrow there. Okay? Okay. The next ones are weird. I was looking at it and I'm like, do they expect me to do some rule here? Some sum rule? Those aren't even the same ratios. So basically on these next ones, just do it. Just do the math. Do this one step at a time. There we go. We got it. We got it. We got it. Okay, so what's inverse tan of 1? What is that answer? 3, 2, 1, go. Pi over 4. How did they get that? Because they do their homework and they've got it memorized and they've seen this over and over and over again. But here's the hand. Root 2 over root 2 would be 1, so it's got to be the over 4. Middle finger is down, if you know the hand trick. Again, I wish the video could be done, but no, I can't. All right, and then what's inverse sine of 1? Where do I get 1 for y, 1 for r, and 0 for x? Pi over 2. Yes, that's what I said. 1 for y, 1 for r, that's 1 and that's r. That means x would have to equal 0. That's the only way that would fit in the unit circle. That happens at 0, comma 1 at pi over 2. All right, and then you can go ahead, I got it. Then you can employ the rule. Now that I got these angle measures, it's cosine, cosine, minus, opposite, sine, sine. Sine, sine, everywhere, sine. Okay, root 2 over 2 times, what's cosine of pi over 2? 0. Okay, and then sine of pi over 4. And then what's sine of pi over 2? 1. So this ends up being negative root 2 over 2. Right? And that's what ends up happening there. Okay, I just want to make sure I didn't. You know what I could have done? I'm a goofball. We could have actually just added these together as well. And maybe I'm going to do that on the next one. Can't you add those angle measures together? All right. So that would be pi over 4 plus 2 pi over 4, which is 3 pi over 4. What's the cosine of 3 pi over 4? Negative root 2 over 2. So that's what I did last year. I think I just I thought, why don't I just add these angle measures instead of doing the sum rule? So I am going to do it on this one. All right. Hey, what's sine of a 30? Why does it keep asking me that? What's sine of a 30? 1/2. Right? You weren't listening. That's why I had to yell. No, you weren't. All right. Liar. All right. So then what is it? It's not a 30. It's a what? 60. Let's be fancy and make it a radian measure. Let's challenge ourselves because that's all we really done. I've only mentioned degrees slightly. Hey, what's sine of a 30? What's sine of a 30? Half. So this isn't a 30, it's a what? It's a 60. That's how you play the game. So weird. And you know what? I'm just going to do this way. Why did we do that the other way over there? Just add those together and then find the cosine of that. What is the cosine of an over 3? Is it a half or root 3 over 2? And then what kind of a half, positive or negative? It's over. Okay, so we could do either or. So I'm kind of glad I did 11 like I did. Last year, I just added them together. I know I did. I didn't even do the sum rule. I just went ahead and added them and just evaluated like number 12. Okay, this is not a bad one to have as a book assignment, because basically you're just writing these out and going from there. So, all right, I don't think it's too bad. Yeah.